First, I just want to discuss briefly the modifiable areal unit problem. So this data is, this is the provincial boundary layer from Simply Analytics, just by province. And this is the provincial boundary layer by census dissemination area. And so if we open these attribute tables, we'll see that I've calculated population density. So this is the average population density for the full province of British Columbia. And so it takes the full population and divides it by the area of the full province. And so we get about 5 people per square kilometer. Now, when we look at the census dissemination areas, we open that attribute table, we see that first off, we end up with many DAs that have 0 population density because they have no population. But we also end up with DAs that have much, much, much higher population densities than the full province. And so the issue here is that depending on the size and area of the unit that we use to aggregate, we end up with different populations, we end up with different shape areas, and then therefore different population densities. Now, somewhat related to that, we've also got something known as the Atomistic Fallacy, where you cannot take aggregated data and aggregate it again and expect to get the proper result, right? So this is the roughly true population density for British Columbia. There's some issues with it in that this shapefile covers the water areas as well, but both of these shapefiles do, so that part doesn't matter too much. Point being that this is the true population density averaged across the full province. Whereas this layer shows population density by census dissemination area. We can symbolize it by that to maybe make it a little more apparent. You can see the overwhelming majority have very low densities until you zoom into, say, Metro Vancouver. And then you have both high population densities. But the point that I want to highlight is that if you open this chart that I've created, this is just a histogram. So we can see here that we've got a histogram of the population density for the dissemination areas. And so we can see that the overwhelming majority have very low population densities. We've got some outliers that have higher values. I think if we turn the counts on, you can see there's a handful of very densely populated DAs and a whole bunch of very sparsely populated DAs. And so you'll notice that this says the mean population density for all of these dissemination areas is 3.75, which is lower than the actual population density for the province. And so this again highlights something known as the atomistic fallacy. Each of these dissemination areas is aggregated, and so we cannot then aggregate those and expect to get the average value because we are aggregating or averaging over a large number of shapes that have different areas and different populations. And so each sample, if you will, is different, both in size and population. And so when you average those, you're not guaranteed to actually get the true value. So that is just one little example. Now I want to show one more thing about error. So in this example, in this model, what I'm doing is just taking this data, which is currently in the BC Albers projection, and I'm shifting through a series of projections and going back to the BC Albers to see how reprojecting data also induces error. So what we're doing here is we're taking the BC province and we're going to the Mercator projection, and then from the Mercator projection to the UTM 10N, and then from that back to the BC province. And so again, there's really no reason that anyone should do this, but this is just meant to highlight what happens if you go through a series of reprojections, how you're going to end up cascading error down the map. So we'll run this, and we can look at the differences. And so each of these ensuing outputs is in a different projection. And so we can see this is the initial shape area. And so let's compare that to the Albers projection shape area that we get when we do a series of projections, right? So we've got this versus this. And so you can see that they are different, but let's just be a little more scientific about it, if you will. We'll take that initial, or that reprojected area and compare it to the initial area and see what the difference is. So we can see that the overall difference in shape area, even doing that complex series of events, is only 7.5 meters. It is not a large difference, right? But every time you do something like this, that error will compound. So if you continue to repeatedly reproject, you would see that that error will cascade even more. And so again, 7.5 square meters is not a big difference, but it is some error that is avoidable and unnecessary nonetheless.